something that you want to test out, and it has some sort of resistance, and you've got a circuit that is providing the voltage that you need for it. You don't really care a whole lot about what the rest of the circuit is doing. You want to know how much resistance it has and how much voltage it's providing. So if you could say all the rest of my circuit is equivalent to this, so whatever this voltage is and this resistance is, if you can break it down to that, then you can put whatever item it is that you're testing in here, and see, and use it. And so having the Thevenin equivalent can simplify things. So we want to find out, to the left of terminals A and B, what is the Thevenin equivalent of this circuit. In other words, if we reduce it to a single voltage source and resistor, then what would the values of those things be? So the first thing I do is I'm going to find V open circuit, the VOC. And what V open circuit is, this is the voltage across A and B when they are not connected. And usually you find VOC because it's in parallel with something else. Because since there's no current running through it, you can't use Ohm's law. It's just, A has some voltage and B has some voltage, and whatever that is what it is. It's not because there's a current running through it. Now, when we look at this particular circuit, and you see this 4 ohm resistor right here, that 4 ohm resistor is not making the resistance, it's not doing anything right now. It's not doing anything right now because it's open, it's not connected, there's no current running through it. And so since that's the case, as far as the circuit is concerned, as far as A and B are concerned, it's like it's not even there right now. So it's just like it's not even there, so we can ignore it. So what that means is for V open circuit, which is VAB, which is V Thevenin, because V Thevenin, we're trying to find the Thevenin equivalent across A and B, that is going to equal what's labeled V1 in this diagram, because it's the same as the voltage across that current source. Okay, so if I had the voltage across the current source, then I would have the voltage that I needed. So when I see that I have a voltage source and a resistor in series. And if I do source transformation and change them to a voltage source and a resistor in parallel, then I've got everything in parallel. And everything in parallel, whatever voltage I get, that's my answer to the problem. So that's really handy. So source transformation. I can take a voltage source plus resistor in series, and transform it to a current source and resistor in parallel. And when I do that, I use V equals IR to find the value of the current source, and the resistor stays the same. So V equals IR, or I equals V over R, or I equals 25 volts over 5 ohms, or 5 amps. So I can redraw my circuit. So I will have a 5 amp current source, and that will be in parallel. The resistor doesn't change, it's still 5 ohms. I still have a 20 ohm resistor there. I have a 3 amp current source. And I'm trying to find VAB. Okay, so is everyone okay with what I did there? Alright, so now these are in parallel. Current sources in parallel, you can just add those together to get an equivalent current. So 3 plus 5 is 8 amps. They're both going up, so I just add them together. My 2 resistors are in parallel, so that would be product over sum. So R equivalent is 5 times 20 over 5 plus 20, or 100 over 25, or 4 ohms. I always like to check when I do a resistor in parallel that the resistance I get needs to be smaller than either of the resistors were to start off with. Okay, so now this was plus, this side was plus, this side was minus. And that works because my current is going down in this direction. So if I call this VAB, which is also V open circuit, which is also V Thevenin, then, and I call this ground, then I can say V Thevenin minus 0 over 4 equals 8. So that's just the voltage on the side you start minus the voltage on the other side over the resistance equals the current in that direction. That's Ohm's law, or V Thevenin equals 32 volts. So we have we have V Thevenin, but to get the answer to the problem, to get the Thevenin equivalent circuit, we need V Thevenin and R Thevenin. So now we're going to do R Thevenin. And the way I do R Thevenin, there's lots of ways to do it. One way is to then connect, I'm not going to do it this way, I'm going to say that it is a way to do it. Connect A and B, and then do, and that would be called I short circuit. So you short circuit it, and then you would say R Thevenin equals V open circuit over I short circuit. So you would find that current, and then you would plug into that to get R Thevenin. Now I don't ever do it that way. You certainly can. It's just not. It's not the way I do it. I like to do it another way that I will show you. So the other way is, and this way that I'm about to do only works if you don't have any dependent voltage sources. If you have dependent voltage sources, it doesn't work. Or dependent sources of any type. Okay, so now what you do to find R Thevenin, and I like to do it this way because there are lots of times that you have to find R Thevenin for some reason or another. And you'll be doing it later this semester when you are dealing with RC and RLC circuits. And there'll just be lots of times. But to find R Thevenin, you change voltage sources to short circuits and current sources to open circuits, and find the equivalent resistance as seen by the Thevenin. So I'm going to take the circuit that I have, and I'm going to redraw it, taking out that voltage source, turning that voltage source into a short circuit. And you don't have to draw this. I'm just showing you that I did it. I turned that current source into an open circuit. So you don't have to draw that. I just wanted to show you that that's what I did. Now in this part of the problem, the 4 ohm resistor is important because we're just finding the resistance of all these resistors. The last one we said it didn't matter because there was no current flowing through it. Well, there's no current flowing through any of this. We're just seeing what happens as I put my resistors together. Now, I said before, as seen from the point of view of these terminals right here. And so one thing that can be confusing is, like, are the 5 ohm resistor and the 20 ohm resistor, are they in series or are they in parallel or are they neither? Well, from the point of view of the V-Thevenin right here, the 5 ohm resistor and the 20 ohm resistor are in parallel. So just imagine sliding that 5 ohm resistor down to the other side. And now, from the point of view of A and B right here, the 4 ohm resistor is in series with this combination of the 5 ohm and the 20 ohm that are in parallel. So I'm going to replace the 5 ohm and 20 ohm in parallel with their equivalent. So resistors in parallel. So R equivalent is R1, R2 over R1 plus R2. So that's the product over sum that I was saying. And then, can't seem to get extra space. My mouse is not working. The pen is not working. Okay, my computer's going crazy. Hold on. It may look like I'm going away, but I'll be right back. See if that worked. finally, yay. Okay, so all I was trying to do here was product over sum. REQ is 20 times 5 over 20 plus 5. It's the same one we just did a minute ago. So that's 100 over 25 is 4 ohms. So now I have one 4 ohm resistor and another 4 ohm resistor, and that is equivalent to one. Those are in series, and that's equivalent to one 8 ohm resistor. So now I can say that our Thevenin is 8 ohms, and my Thevenin equivalent circuit is a circuit that has a voltage source and a resistor. The resistor is 8 ohms, and the voltage source was 32 volts. Okay, so are there any questions on that one?